So the title of the presentation is basically getting help from VSI on your migration. And we explicitly decided not to specify the type of migration, right? Because there are so many, and we decided not to put it on the title, but I'll talk a little bit about which migrations we are referring to. So the agenda for today, I'll talk a little bit about the team, because this is a presentation of work that is done primarily by the professional services team. Then, like I said, we are finally going to specify the types of migration. We're going to go through the migration process. So it's basically one of the standards we are using to how they deploy it. And to make things a little bit more interesting, I particularly put some emphasis on number 4, which is the examples of migration. I tried to bring some of the technical aspects of it, some of the things we have seen, and particularly some of the things we have measured. So there is some information there on what numbers we could get out of it. And then a little bit, very quick conclusion, and then time for Q&A. And the original idea was really, that was even before they asked me, there was 30 minutes, 15, and coffee break. Now I'm going to try to do even a little bit faster, something like 20, 25, 15 minutes Q&A and coffee break. Yes, so the really cool slide with all the photos. It was super complicated to get the photos of everyone in the team. And
Robert tried really hard.
Yes, not only Robert, I do have to say, but you can actually appreciate some of the guys here. And I'll not mention everyone's name, but you do know these guys. And this
changed the, how did you pick the numbers though?
Yeah, there was actually Chiara who mixed this slide. But I'll not mention name. I'll just mention one thing, that as part of the original presentation that Daria gave today, we are also trying our very best to bring more members to the team, particularly the younger ones. And we do have 2 other hires which are not listed on this slide, which we are now training to come and help the more experienced generation. So we have the ability of basically keep this running for many, many years. Then obviously the types of migration. So we're mostly talking about the last 5 types, which is OpenVMS Alpha to OpenVMS 86, Integrity 36, and bare metal to Alpha Emulator. And then all of the above, you can add the spiciness of the cloud or not. And that is particularly interesting because, as most of you have noticed on this bootcamp, it's a fair amount of talks about the cloud. The migration process, it's 5 simple steps: contact, discovery, technical solution, statement of work, quotation, and implementation. Contact us, very most common way, fill in the form. It's a fairly big form. We try to minimize the number of the red stars, which are essential. And Jan will tell you that is the best way to do it, but you don't have to fill the form. You can also just pick up the phone and call us. You can always just send us an email. You can make use of the pre-discovery server. So this is particularly interesting for the customers which do have a system, but do not have too much understanding of what in their system. So their understanding is before what is needed as an understanding to be able to fill in the form in a very proper way. And yeah, we can also help even if you don't know which migration you'd like to proceed. So, or even you might understand that there is a possibility of such a migration, but you do not know the trade-offs involved with it. A very good example is if I move to version 8.4 to L3, does that give me better support? And one of the answers is yes, because we are actually not going to have the older versions as part of the standard support anymore quite soon. So this type of decisions that sometimes it's not so much about which migration, not so much about if the migration is for me, but actually which migration should go through and what is the pro, what is the con. We can definitely help with those. So it's not only a decision that you have to make, I want to do migration. You can even come to us, should I? And we can definitely help. And obviously, we are not going to always say, yes, migrate everything now, because sometimes we understand it's a trade-off. All right, then step 2. After we pass this initial phase of contacting, getting to know each other, getting to know the system, we go and we list on step 2, part 1, all the applications you have. And this is what we call the part 1 of the discovery service. What are all the applications? Vendors? What is the version you currently run? Then we look on our internal database, which has more than 2,000 entries. What is the status that we know of the latest version that they have released? And has that version been ported already or not? What is the status of the port? So it could be that it has been ported, but it's a preliminary release which is not commercially available yet. Or it could be that they're just rewriting as we speak. Or it could also be that, yeah, it has been ported, it has been compiled, but it has not been tested yet. So our internal database with more than 2,000 entries basically knows exactly for these. And when I say this, is VSI's own, it's partners, and it's also third parties. So we know who those people are, where the apps are, and so forth. Of course, from time to time, we do encounter some entries which are not in the database, and we take on our own to update the database and contact the original software owners and whoever has written those applications to update the database, and therefore issue a better recommendation for the customer. Then output of this, we actually have a state for each application. So is it possible or not? That is the final goal. Could it be an application that has never been launched for x86 and will never be ported? That is definitely no go. Or is it something that is on the way or not? So at the very end, we want to have a green, red, go, no go for each application. And this is all presented in a report that we try our very best to make both for technical people, but also for some of the stakeholders that may take the decision. So for technical people, we do mention all the versions, we mention the software manufacturer, the status of the test, things like that. But then, of course, for the stakeholders, it's mostly a green, red, go, no go decision. Part two of the discovery service, we look at the system itself. So a very good example is it an isolated node? Is it stretched systems? What sort of changes we need to perform on the system? So a very common discussion is, would it be possible to still have a common system disk or not? Is there some side effect of not having one? Do we have any forecast of performance impact or perhaps usability bottleneck? A very good example of this, and we are not too afraid to mention, is that some of the compilers, when you're running on x86, they do take longer. So we do produce still valid code and everything is fine, but if that is a parameter that is super important for you, we can definitely reconsider. We can have a hybrid migration where we have some machines in our node migrated, some. Then, of course, as part of the usability bottleneck, performance bottleneck and usability bottleneck, one thing we try our very best whenever possible is to suggest mitigation strategies. So a very good example would be just increase the number of cores, or perhaps choose cores with higher frequency. And part of the migration service that we offer is indeed help with the procurement of the hardware. Not that we are going to contact the hardware providers for you, but we're going to give recommendations if so wish. And very last is it even worth doing immigration, right?
We're already going to have an alpha off to the side with the x86, screw the integrity,
right,
and do that. So
right. A very good example is, so for instance, right now Oracle is indeed porting the RDB, but let's say you need the migration for tomorrow, and you cannot wait for the RDB to come in 6 months, something like that. It's very possible that one of the suggestions we would make would be a cluster which you keep 1 to retaining nodes and we migrate the rest. Right, technical solution. So this is actually super straightforward in the process because this is the first iteration of the technical solution. So we're going to present how we're going to do the migration, the precise steps of the migration, which softwares are going to be installed, which softwares are not going to be installed, and we're going to iterate with your team. So the whole idea is that before we even sign the contract, we are going to iterate and we're going to discuss which parts of the migration should we actually remove, which parts should we include. Perhaps there are a few steps that we should improve how we're doing things. Perhaps we do have some sort of timeline deadlines that we should be aware of, and therefore some parts of the migration we should do a little bit faster, whereas some parts a little bit slower, and so forth. So the technical solution per se is a very, very, very iterative process. We are indeed very experienced on the migrations, but you are experienced in your own business. Therefore, the need for the iteration when it comes to the solution. Then step number 4, the not so interesting thing, is all the legal paperwork that is involved with this. And we try to be, as friendly and concise as possible by using a statement of work. And it is still legally binding, but it's not one of those 100+ page that you just click accept without really reading. So yeah, it has to be there. So. Then step 5, the implementation. This is, of course, hard for me to explain from a too top level perspective, because this is the part where things get very different between one migration and another. And it could be even within the same customer, because you're migrating different types of systems, the implementation is completely different. But as a very basic, we try to give some examples here. So for instance, first and foremost, we need access to the system, right? And for some systems, this could be actually in-person access, which is getting more and more rare these days. Whereas for some systems, it would be just an SSH and a key. But the most common what we see is actually it's SSH key, and then you have to connect to a button or a jump box. And particularly nowadays, one of the things we have to have in mind as we are talking the migration process is the firewall config. We have had so many times that we have a contract signed and we have the SSH keys, everything's fine, and we just cannot connect to the system, right? Because the IT person who is responsible is on India, which is 7 hours plus, and then we need to ask permission from the CTO to open a exception on the firewall. So there is always something related to that. So we already try to talk to the customers at the inspection phase that we are going to need to have support from your IT team if you do have this type of firewalls in your organization. Then, of course, our experts log in, start the work. And for most projects, we do have recurrent progress meetings and we do have recurrent technical meetings. Sometimes they are separate, sometimes they're the same. We do prefer the separate so that we can actually talk super nerdy in one of those meetings when we're technical, but then we can also be much more high level if we do with the management. And there was a lot of blah, blah, blah. So let's show a little bit of the track record, right? Unfortunately, I cannot name the customers, but this is what I call the nameless case number 1, which was a migration from VMS version 8 to 9.2.2. And this was an interesting example because we did talk with the customer and we precisely gave a recommendation of the hardware purchase. And the hardware purchase for this example was not so much on the performance of the system as a whole, but it was actually on a very strict requirement that they had for performance. So what actually meant for this customer is that we reduced the number of cores, but all the cores that were purchased, they were actually much higher frequency because of the type of application that they were running. This project also involved a lot of training documentation for the x86 deployment. So this was a Tanium to x86. And we helped a lot to support the customer to develop its own application and the extension of the application. So we actually helped the customer to look at their own source code. We helped the customer how to compile some of the compiler optimization flags, things like that. And during this process, we even found out some of the bugs in our compiler and in our debugger. And I'm not so ashamed to say this, but because they were our partner during this migration process, they did get access to some early versions, early releases of the compiler. And very good example was the DEC Windows debugger. Then the nameless case number 2 was a customer with many nodes that they had issues. But when I say many nodes, by the way, we're talking about more than 200 nodes. And their IT, their basically CTO was very, very worried about the lack of possibility of signing a hardware maintenance contract after 2025.
Had that one been signed with like Hewlett Packard?
Exactly.
Gotcha.
Yeah. And because of internal ways that their maintenance contracts were handled, they were not allowed to sign with third parties which were not the original manufacturers of the hardware. Right. So for some customers, we do understand that is a possibility. You just sign with a third party, and then it's no longer HP; it's someone else that comes and does all the, grease on your hands details on how to keep your server running. But that was not the case here. So we had to come in and basically help the customer to do a migration to x86 so that they could keep having a HP hardware maintenance contract. What is the main issue here is that there was one third party, very, very important application, which had not been migrated yet. And the work had not even started in that, and the provider of that application was not even considered. So as part of our work here, there was a fair amount of technical work, but there was also a fair amount of political work to get the original code base of that third party into VSI's possession, so we could also do the port on the code base compilation.
And you did that?
Yes, through licensing agreement and things like that. And that was a major work. And this project, it hasn't been finalized yet. It's still ongoing. And some of the other issues we have seen was basically mostly related to the floating point issues. Brett particularly has worked a lot on this, and part of the discussion he has on the floating point was many things that we learned in this project. There was a database port as well. This was one of the customers that did not want to wait for any database and just wanted to have something that is already ported and tested as of today. And one other interesting thing that we saw with this particular customer was some issues with concurrency queuing. And basically semaphores and synchronization of access to a limited number of resources. They were actually using code original from VEX, and they had been running fine in Alpha, they had been running fine in Itanium, but there were some issues as we tried on the x86. And it's one of the things where we got improvements here, but we're still with work ongoing on this area. Then nameless case number 3, this is particularly interesting because this case is a lot of numerical work. So the objective here was not so much get our hands on the customer system and do a migration, do a change. No, the customer had already performed a migration, but they were not satisfied with one or two aspects of the performance of the system, because they had a very, very explicit requirement on terms of latency of the system. So performance-wise, bulk output, time to process, all these sort of things were fine. But the predictability of the latency was something that they were not very happy with. So what did we actually do? By the way, they were running a hypervised environment, and the idea is how do we have a more predictable latency? So basically, how do we reduce the jitter? And the performance was already good enough overall, but we need to reduce this jitter. What we did is in our own lab, we created 4 different combinations, and combinations of hardware and two hardware and 2 software versions. So we call them VMS J01 all the way to VMS J04. And that was basically Gen 10's 922 all the way to Gen 11's 923 and the combination thereof. We already had a somewhat idea that VMS J01 and VMS J04 would likely perform better, and I'll show some of the results later on. And what did we actually try here? We tried 9 different sets of configurations. I'll show them later. Basically, it's a mix and match of BIOS settings, host configuration, and VMS configuration. And when I say host configuration, it's because they were running KVM on Linux. So the hypervisor had on its own quite a fair amount of configuration to be done. And the customer was very explicit for us to use the VOOPS test for the jitter measurement, which is a quite old application, but it runs on x86, absolutely no problem. But it's basically a requirement internal from the customer. That's what they were used to compare the jitter with. So that's what we did. This is a table with the results we actually got. So the VOOPS test, we actually put it to run on loops of 100. And each loop would take about, I believe, 15 to 60 seconds, depending on configuration. And it would print out VOOPS performance scores. So basically the numbers we are seeing here are performance scores. So 589.6, 592.4. So you can see there is a certain variation on configuration 1. As we move on to configuration 2, you can see that the performance scores, they're slightly closer to each other. And the coloring here is for a given column, what is the number that appears the most? And that number has been colored in blue. So for instance, as you can see on config 2, the 924 is the number that appears the most, and every time that number actually appears, we did color. And we move on basically through the table. I'm showing here only parts of the table, very small parts, maybe 20%. As I said, we have basically 100 rows. But here you can already see that configuration 6 and configuration 8, they perform a little bit better than some of the other ones. The interesting part of this project is that it was a lot of statistical analysis. So of course we had to spend quite a amount of time fine-tuning the system, trying to figure out what settings would be not only good on their own, but how would they match with each other, how they go together for this hypervised environment. But then in the very end, when we got the data, we had to do a very big statistical analysis and iterate a little bit on it, particularly on how to mix and match all these variables. And yeah, we were talking about average, mean, mode, harmonic mean, and all sort of statistical things, which was particularly interesting. It felt almost like going back to university and studying some of the engineering classes. And interestingly enough, when we did the analysis, not from a eye point of view, as is the cell white or is the cell blue on the original table that I showed you, we actually found out from statistical analysis that configuration 3 was the one that was with the smallest amount of jitter. So from a statistical analysis, we can actually say that the deviation for configuration 3 was less than 0.2%, which is very, very small. As a result of this project, we came back to the customer with the conclusions. We present all the results and the statistical analysis, and they are now in the process of implementing configuration 3 and trying to run on their own system. And of course, the system we have was as close reproduction as we could of their systems, but they do run on different CPU, they do run on different hardware. So it is one of those projects that on our yeah, it will definitely be more iterative. It will roll for a little bit longer, and the idea is, of course, later on we want, if possible, to try some of the configurations also on the customer system, so we have a much more closer to reality results. But from what we had access, which was basically our lab, this is something that we got as result. Then nameless case number 4, which is actually, this is actually not a one customer case as were the other 3, but this is a combination of types of things we also see of particularly smaller projects. And we see some of these in Europe, but there is particular emphasis on a lot of these in, sorry, the other way around. We see some of these in US, but there is a particular emphasis on this in. And they're mostly related to IT certification. So sometimes the customer is like, can you actually provide us a paper that your system can do X? And okay, what sort of paper? We need to have a paper, we need to have a sign, and we need to have basically that you have to prove that there has been some sort of test that your system can do X, Y. It's according to a certain specification. So it's a lot of, it might sound like paperwork, but in the end, it does involve a lot of technical work on the lab machines to be able to certify one or two aspects of the system. Example of things, can we actually guarantee that we have full logging of all activities in the system, right? And which is something that we might say, yeah, we have full logging of all activities in the system, it's designed by this, but let's go to the lab, let's see what sort of configuration is needed to actually implement this. So when we do issue a certificate to the customer, it's like, yes, your system is able to fully log all activities, and this is the configuration you have to follow, right? This is basically how you have to set up your system. Can we full log all the connections? So another type of example. Can we certify that a given system works as per example? So some of the examples is VS, NFD, SOX, ITGC. There are a lot of these current standards that customers are starting to require for their systems. And another good example is like, what is the what would be the best practice for disaster recovery, right? So we do have sometimes to issue documentation on this and certify that a given customer system is set up for the best practice for disaster recovery. Then nameless case number 5, and this was one of the most recent ones because, as you can see, it involves the Oracle Cloud. This is a project we started basically 3 months ago. It's still ongoing. And this was very interesting because usually when we talk about migration, we generally think that we are talking about a change in architecture. But this one, the customer had already ported to x86. And for us, this was a particularly interesting case to take for a pilot on the cloud because the port of the x86 was already there, which meant we could have a comparison benchmark against a system that is fully running. It is actually already in production. It's just bare metal on premises of the customer. So they're running hardware on premise with VMware. And then as we are moving to the cloud, we decided to go with KVM just for a slightly different approach. Also because the cloud was set up to support that on a more like easy manner. What is the justification for this is very similar to what we have heard from the presentation of the cloud today from Oracle, is that many IT departments, they actually mandate nowadays that there should be no hardware on the premises until date X. For this customer, it was basically until the end of 2025.
They have to get rid.
They have to get rid even
before the
end of 2025, and they were already running on x86. So this is not the 2025 Itanium doomsday, it's just 2025 internal doomsday, right? For whatever reason, sometimes it's just a CTO that likes not to have any hardware in the cloud. Sometimes it could even be that they are running hardware on premise, but basically they have a team of 3 people just to keep running the hardware and they want to actually just outsource that. So there are multiple different reasons why there will be. And we did understand from the customer that we were actually the last hardware on premise that they have. From all the other applications, from all the other servers, they were all moved already to different cloud providers, and we were the last ones. And what is the top helicopter view here? It's a copy of the system in the cloud. right? So we're going to take the hardware on-premise, which ran on VMware, so it was already hypervised, which thankfully is very nice because then we do not have to worry as much with device drivers. And when I say as much, it's because we are indeed changing from VMware to KVM. So it's not a full exact copy, but it's as close of a copy as we actually can. And that meant that we did take a snapshot of their system. The system's still running, of course. Now we are slightly diverging, but it's part of the business here. And we are copying it to the cloud, even to the extent that we are going to have for a quite amount of time, about 2-3 months, the version running on both sides. And then that is going to be used for performance comparison, all this type of things. Part of this project, which was not necessarily a request from the customer, it was our own initiative, was to automate as much as possible the installation configuration of the Oracle Linux, and also the deployment of the OpenVMS. So for the Oracle Linux specifically, we are foregoing VMware because of the cost, exactly. And the installation of that Linux and the configuration is all done in Bash scripts, and we have our tools to basically go in there and get a snapshot, a configuration before we deploy the system, and just put the system exactly the way we want. Whereas for VMS, we're looking now into using Genie to do the automated installation.
It's just external tools.
Yeah.
You have to say it's not available.
Yeah, it's not available. It's an internal tool. So goes for the tools we are using for Linux. Basically, the scripts we are using for the automation and the configuration, they are all internal. So, I mean, we cannot make everything open source and distributed, right? So some of the stuff we have to keep at some point. All right. So what does this involve? Of course, it's a best approach to have things automated, but as it is our first run, we do not want to do everything automated. As a first trial, we are aiming for 60 to 70% of the work to be automated and scripted, which means that there will still be quite a fair amount of fine-tuning and cross-checking. And that is essential, particularly for the high impact. It could be low probability, but high impact issues. So a good example is we do not want to automate all the disk initialization, partitioning, format, all this type of things. We want to do those things by hand to prevent any data loss, at least until we're more familiarized with the installation methods. So there are a few other things as well. When we're handling the customer data, their software, things like that, we are doing manually as well, just in case there is any sort of bug or unpredicted behavior on the script, on the installation procedures that would cause loss of data or potential like distribution of data to a place we would not be willing to. So there is still a fair amount of manual, just to say that it is an ongoing case that we are deciding to automatic, but also in much manual steps. And one of the big areas that we're spending a fair amount of time here is on the network configuration. The way the software of this customer works is they connect actually their running instance into a Amazon Web Service that then distribute a fair amount of network connections. They use more than 10 different data brokers to gather data that their software depends on generating then a reply to an external query. And yeah, it's a lot of network configuration involved in this. Right, final comments. Why choose VSI, right? Because a lot of the migration you could just do by yourself. You could hire other companies. You could just not do it at all. So why actually choose us? First and foremost, it's ours. The operating system is ours. We know it better than anyone. We just go. We have access to the source code. We talk to the people. We know who to nudge when the compiler is not exactly at the state that the given customer is hoping for. Second thing, it's a quick turnaround. We have very fast access to patches. So the very good example is to provide customers whenever possible access to these internal releases. Of course, we are not going to provide someone a release that hasn't been tested. It must be at least internally tested. But you do get a quicker turnaround than most people. We do understand a lot of the ecosystem as well. So this is one of our objectives here, is to act as a centralizer of information about the ecosystem. And the very good example is the database of more than 2,000 entries of software and their stages. So we want to be there. We want to be the person that knows on how everyone else is doing, whenever possible, also help the other providers. But we want to have the information of that, and we want to be able also to distribute that information. So we want to be part of the ecosystem, but playing a very active role. And last but not least, we have a super experienced team, right? We are, of course, trying to recruit new people now, train new people, so we keep this experience going. But together, our team on the professional service, we're talking between 150, yeah, what is it? Between 100 and 150 years of experience. So it's a lot of people that have done a lot of migration, a lot of problems. They have solved a lot of things. They have talked to a lot of customers. Yes, Q&A. So like I said, my objective was to give you guys also a bigger coffee break.
I have no questions. Yeah, what can we help you with?
Yeah.
Yeah, no question. Thank
Thank you.
Thank you very much.
Yeah, thank you.